So given that so far we looked at how to build a decision tree kind of in theory and we ignore the data size, let's now talk about the algorithm that does the decision tree building using MapReduce. So the problem we are looking at is how do I build a tree using a giant data set that lives on top of MapReduce. So the idea is, given a large data set, I want to build a decision tree. What are some general considerations that I want to take into account? So the first one is if the whole tree will be relatively small. What I mean by this is the data is big, but the tree itself is relatively small. So imagine it's like 10 levels deep. If it's a binary tree, this means it will have 2,000 nodes or something. So it's a small thing. So tree itself fits into memory, but the data is very big. So the data set is too large to keep in memory, and the data set is too big to scan over it on a single machine. So we really want to have this data set be distributed across a large number of machines. And the idea is that because the data set needs to be distributed, we'll be using the MapReduce framework. Just to remind you how MapReduce works, the idea is that we have our input file split into the chunks. Then we have pump the chunks of the input file through a set of mappers. Mappers extract key value pairs, right? We have a set of keys and we have a corresponding set of values. Then this data gets sorted and it gets passed towards the reducers, where all the key value pairs that belong to the same key, for example here everything that has the key B goes to the first reducer, and everything that has key value A goes to the second reducer, and for example also all the C's go to the first reducer, right? So the idea is that there is the shuffling step, and then the reducers collect the values, and each reducer produces its own output. So the question is, how can we use this kind of MapReduce computational infrastructure to learn how to build trees? So the particular approach we will be looking at is called Planet. And this was a research paper published by Google a few years ago, so 3-4 years ago. And what Planet is, it's simply a sequence of MapReduce jobs that builds a decision tree. Our setting in this case is the following. We will kind of focus on a subset of all possible categorical attributes and so on. We will only consider numerical attributes. We can think of them as discrete, meaning integers, or continuous, like real values, but we have no categorical attributes. We will think of predicting the target variable y to be a continuous value or a numerical value, so we will think about a regression. And we will limit ourselves on binary splits, right? So our decisions will be of the form, is x less than value v? And then if yes, go to the left. If no, go to the right. As I mentioned, our decision tree is small enough, so mapper can keep it in memory, but the data is too large to be kept in memory. So our overall system architecture will be something like this. Right? We will want to have a sequence of MapReduce jobs that read the input data and process it. We will also have the master node that keeps track of everything. And we will also keep separately in the memory the model that we have built so far. We will keep some attribute metadata information. And the master is also responsible for saving intermediate results. What the MapReduce will do is it will do in particular two things. It will try to help us find the best attribute and the best value to split on. So we will call this find best split, and then it will also kind of keep building the tree. So the expensive part here, or the part that is computationally very expensive, is finding what is the best split. And we want to utilize MapReduce to help us find the best split. The way we will build the tree is we will build it in levels. So we'll first build the first level, and then we'll build the second level, and so on. And at every level, for all the nodes, we will want to decide what is the best attribute to split upon. So let's think about building the tree, right? As I said, we are building the tree level by level, where we will have one MapReduce steps to build one level of the tree. So if you want to build a tree that is 10 levels deep, we need 10 MapReduce jobs or steps of iterations of it. And in particular, kind of at high level, the mapper, what it will do, it will consider a number of possible splits and on a given subset of data. And for each split, it will kind of store the partial statistics, so that then the partial statistic is sent to the reducer, the reducer collects the partial statistics and determines the best split. So basically the idea is that given the particular feature and a particular split value, if I have our big input file that is split into chunks, each chunk is sent to a separate mapper. This mapper will compute some statistics of how this given attribute and this given value, what is the quality of the split. All these partial statistics will be sent to the reducer, who will then output the final score or the final quality of the given split, and then master then decides which split to take and grows the tree by additional level. So this is generally the idea. The mapper will allow us to take this big data file, split into chunks, compute subsets, statistics of it on subsets of the data. A reducer collects the thing and lets the master know to make the final decision. So in terms of the overall infrastructure, the mapper loads the model into the model we built so far into the memory, and then also information on which attribute splits to consider. And then a given mapper only sees a subset of data. The mapper drops each data point to the appropriate leaf node L. And for each leaf node L, it keeps the statistics about what is the data that reached L and what is the data that is in the left and right subtree under the given split, right? So the mapper sees a set of splits S, sees a subset of our data set, and then for each leaf node, it keeps track of which data goes to the left, kind of left of the leaf node, and what data goes to the right of that given leaf node. And then, as I mentioned, a reducer will take all this partial information, combine it, and determine the best split for each node in the tree at the given level that we are currently building, right? So the idea is that we are currently looking, let's say, at the third level or fourth level of the tree. So the way, now that I told you about what the mapper is doing and what the reducer is doing at one level of the tree, now how are we kind of building the whole tree? The whole procedure breaks down into three types of MapReduce jobs. First is the MapReduce job that we call initialization. We call this once at the beginning of the building procedure. And basically the idea here is for each attribute to identify values to be considered for splits. Then we will have a sequence of MapReduce jobs that are basically finding the best splits. So we have one MapReduce job for every level of the tree. Here the idea is that we want to find the best split when there is too much data to fit in memory. And then we also have this last part, which we will call in-memory build. This is the thing we want to run at least once, where basically it's a similar thing to the build subtree function I already showed you. And the idea here is that once the data is small enough, we just want to go and build the whole subtree at once.